how they arrange the trapezoid to find how to get the area. Huh? The trapezoid, yeah. They find the area of it. Does everyone remember? Did everyone do the trapezoid? Did no one do it? And this was last week, but Brother Piper wanted to make sure we went over it today since we didn't get to it last week. Yeah, you got two of them kind of out. Go for it, Erica.
So you want me to explain it?
Explain it. Board, chalk. You want colored chalk or you want white chalk?
Can I have colored chalk?
You can have colored chalk.
Yes.
I love colored chalk. It's so pretty.
What color one is? Okay, so I had my friend explain this to me because I was kind of confused. But so here's your trapezoid. And she was telling me how to find the area for this, that's what we're doing right here, is you want to take this and kind of just flip it and reflect it. So, oh, that's pretty. Okay, so there you go, and you have that. But so now it looks like a parallelogram. And so you want to take this triangle here, and bring it over here. So then you have the rectangle. So it's just a really long rectangle. And then so you have, if you have input here, you have a base here, and you have a base here, and then here you have your height. And so when this gets flipped, the base here goes up to here. And so now you have this base, which is what I call base 1. And then here you have base 2, and it comes one long side. And so your formula to figure out a trapezoid would be base 1 plus base 2 times your height. And then you must divide it by 2 because you're kind of working out 2 trapezoids and we want the area for 1. Does that make sense? Right? Okay.
Does anyone have any questions on that? No?
Can we just go, I can understand it, but if you go over it once more.
Yeah, that's fine. We got nothing wrong with that. Okay. So if we start off the beginning, can everyone see the orange chalk? Cool. So we have our trapezoid, we have our base 1, and then we have our base 2 up top, correct? Then we have our height. And so this is a new shape, and remember what Brother Piper taught, that there's always a way to bring it back to the original, to either parallelogram, thank you. Yeah, I don't speak correctly either for that matter, but or a rectangle. And so what Erica did is she made it into a parallelogram. And what she did is she took the original image and she just reflected it. And reflect means to basically turn upside down. And that's what she did. Now when we do that, our base 2 up top comes down to our base 2 on the bottom. We still have our height, and we have our base 1 up top. Now when we have this, we have our parallelogram. However, you know, we have 2 bases now. If we do that, when you do this, you can't count it twice. So you have to multiply. So you have base 1 plus base 2, but you can make sure to divide it by 2. That way you're not counting twice. Does that make sense? Okay. So that's where base 1 plus base 2 over 2 comes from. And the height is just height. And that's the area. Parallelogram. And that, base times h is parallelogram, and trapezoid is b1 plus b2 over 2. Does that make sense? All kosher? Cool. Now, did anyone do any other way?
You want me just to jump up on the board?
Go for it. You can use same color. I have yellow, red, blue, green. I like blue.
So
So I just took my piece of paper, and here's my trapezoid. Yeah, that's really pretty. And I took off this triangle, and if this was made correctly, you'd be able to just put it in. This wouldn't work for all trapezoids, it only worked because it was an isosceles trapezoid though. So then this, like this. This way over here. If that makes sense.
So what was your formula?
So, it was just the base times the height. But it wouldn't work for all trapezoids.
One more problem. Okay. Did anyone come up with, did everyone understand that way? Did anyone come up with a third way? Okay. I'll show you the third way then. How about instead of cutting off a triangle, let's use red. What we did is, how about we just cut it in half? And so what we do is kind of we'll make another parallelogram, except our height is now cut in half. So we have 1/2 times height times B1 and B2. Does everyone see how all of these, if you notice with, bless you, triangle, since we're taking out a triangle, we can just do the area of a triangle, and that gives us our half times our height, and then we still have our base 1 and base 2. Does that make sense? We're all good? Cool. Let's move on. The next part is dealing with the circle. There's you were given a circle about 24 sectors and asked to find the area. Who would like to come up and show it? Show what you did, how you found it. Come on.
When I put up my triangle, I arranged them in pieces like this, and then I put them top to bottom so that they were kind of like this, and it can make either a rectangle or a parallelogram.
Cool. So if we just continue this out. So the circle, how did you do the formula from this afterwards then?
The formula for
Yeah,
it?
the area. Like using your process here, how did you find the area?
I just did the one that we usually doing in class of like either base times height or length times width, which is the same thing.
So what would be the base then? This question is open for everybody. Now, your right is part of the circumference, but is it just the circumference or is it something else?
The radius. Well, no, that's the height. Half of the circumference.
So if she did it double stacked, will she have half the circle on the bottom? And,
So, yeah, I did that.
okay. So you did it kind of differently actually.
Yeah.
So
I just did a long
yeah, hold on. How about
parallelogram.
come up and show it? Show us, and then we'll do it at the same time. Here's mine. The long way, that's you gonna show,
That's,
the double stack way. No, no,
Do you
no,
want me-
no, come short.
okay, just, do you want me to do the formula too? Or?
Yes, ma'am.
Okay, so yeah, you saw the picture. I'll just kind of do a couple drawings on this.
Neither am I. I draw stick figures better.
Okay, but I'll do one more. Okay, so there's a little parallelogram. So, the area of a parallelogram is base times height. And so then, I'm trying to think, because I did this a long time ago. So we have two bases, right? So 1, 2. So we go 2. Oh, I don't remember how I did this. It made so much sense. But then I add, maybe you can help me.
I can do that, yes.
Okay, times r. I got that somehow.
Somehow.
So because half of the circumference, if like I had all of this,
Mhm.
that's like half of the circumference, so that's another half of the circumference, you know, all the way around. So that's why I did half of the circumference is the base, and then the height is the radius. Does that make sense? Because one of those, when you have them in a circle, it's the radius. Okay, yeah, so that's where I got it. And then from there, I went, okay, so then when you distribute, that's 1 circumference times 2r. And then we know that, we talked about this last class, that pi equals the circumference times the diameter. And that's where we get a equals pi times r squared, like the y.
So what's the formula for circumference?
Circumference, pi times d, divided by d.
Okay. So
Pi divided by d. I think I may be confused. I don't know, it's been a while, so I can't
nothing wrong
remember.
with that. The formula for circumference equals 2 pi r.
Oh, pi d.
Or, well, 2 times r, yeah. D equals 2r. Yeah. That's right. Because to find pi, you have to take circumference
Or
divided
r
by.
squared.
No, to find pi. Remember from our activity last week, when you brought your circular objects, your plates, or your buttons, or your water bottles, that he asked you to find their circumference, which is this point all the way around, and then the diameter. And when you divided the circumference by the diameter, it should have been relatively close to 3.14, which is pi. This means approximate to pi. And so, since you're right, you're 1/2 times circumference, because it's only half of it. And so when you do your circumference here, so 2 times 1/2, and remember the 2 pi r, times r. And this is the 2 comes from as well as either or. We then, as we multiply it out, we get 1/2 times 2 is 1. We have pi, r times r is just r squared. That's where that comes from. Now with your formula, is it Anna? Aubrey? Okay, thank you about that. You have a fourth, and a fourth. So you would do 1/4 times the circumference times, you have 2 r's in this case. Does everyone see why there's 2 r's?
I don't. Can you explain?
That is just fine. So, if you look at here, I know there's a lot of spaces, because apparently I can't cut, or glue. But when you do this, notice how there's 1 radius here, and there's 1 radius here. And so when you're doing the height, it's 1 radius plus 1 radius. So it's or 2r.
Got it.
Cool. So we have 2r here. Then we continue on, put in c. that equals, so we then have 1/2 pi r times 2r, and that just gives us pi r squared. You good? You kosher? Makes sense? Clear as mud? Cool. Moving right along. So then in your homework you were told, you were given a dot board, and then there you were told to find squares. And who would like to come up here and show us what squares they found? It's alright if you didn't find all the squares, by the way. I didn't find all the squares initially either. Or, oh, I have full faith in your ability to find at least one square.
Oh, so I did like 3 by 3. Oh, I have this down. So just like that. So then the area was 9.
Thank you.
Is that all of them?
That is one of them. You are entirely correct.
Just another one?
Yeah. Oh my god.
Okay, I just did the whole. And that's 16.
Are there any others you think? Or claim? Claim?
So there's also a 2 by 2. Four.
Now there's one more square that is, what's the term for it?
Okay.
Upright. That's a 1 by 1. And that's a 1. I claim that. And you can challenge me if you want. So, is that all the squares you think? What type of other squares are there in here? Tilted. Where are they? The pen is mightier than the sword. And who will take this pen? Bob, come over. Take care of this. Oh, come on over. You can do another one. Unless you claim there's only one.
This one was really simple.
There's two. Okay, great.
I don't remember what the area was.
That's okay.
Okay, so there's also kind of a 2, only it's not. I don't know. Actually, we'll pretend I erased that. I don't know.
Well, you're right. There is a square there.
I know, I just don't remember how I split it up.
How about we, let's make sure I do this correctly or not messed up. What if we broke it up as a triangle? Because you could do this, but then you have this weird shape afterwards, right? So let's change that a little bit. Bless you. Where do you think we would put the triangle? Or triangles? Where? Diagonal. Like this? So if we did that, how would we find, with the information given, how would we find the area then? Any other ideas how we could do it? You have an idea? Raise your hand.
I don't know. If you have to do 2 lines and then you end up with like a rectangle, if that makes sense.
So something like this.
Yeah.
So you have 2 triangles and a parallelogram.
Yeah. Basically.
I like that. And can we find the height? That's right, it's 1. Can we find the bases of all those? Well, we can come pretty close. We know that it's not going to be greater than 3. So let's think, how would we find that? Well, we know the height is 1. And we have this. What if we know there's 1 in there. But how are we going to tell about these 2 areas? How are we going to find that? Well, here's a thought. Since it's a square, we know that each side is the same length, correct? Well, if we use this triangle here and found this length, whatever it is, do you think then we would find all the lengths, right? So instead of doing the parallelogram, how about we just have that one triangle and find this side. And that would give us, and then we could multiply it and find the area. Would you agree? Well, so that's 1, the height is 1. So, wait, that's what you learned today how to do. Never mind, I apologize, that's my fault. You learned how to do all this today, actually. I'll just tell you it's 5. Is that right, 5? Yeah, 5. And you'll learn why today. Well, a better way than I can verbally explain. Any others? Or how many other squares are there, I would say? How many others are there?
Well, I don't know how many others there are.
How many would you think there are? From your sheet.
2 more.
2 more. I am going to say you're right.
Okay.
Would you like to show it?
Show the other ones?
Mm-hmm.
I can show 1 more.
Show one more.
I don't know if I can show both.
That's fine. Oh, that's how we do it. Yeah, that makes sense.
I guess I should have felt from behind. But I need to see it a little bit better. So then what I did was I actually did make the, did I make a square? I can't remember how I did it. I made a square like this, and then it's kind of like this again, and so that would be 2 inside the square. Then what I did was like this. Oh, but those are still us.
Mm.
And so then I kind of just broke them all up into triangles. So the whole center is 2, and then this would equal another 2, so that's 4 so far. And then this is 1, 2, 3, 4, so the area would be 8, because you just add up all the halves.
That's correct. Which, doing that reminded me how to do number 5. This one, actually. So we have here, we have our box, great thing about wet erase. It takes so much effort to get them off. We do this right here. I'll just write this. So that's one in here. What do you think these are? What do you think the area or the of each of those blocks are? 1. That's exactly what it is. Because if you look, remember that since the triangle, right angle triangles, if you bring this over, it'll complete the triangle, which will be 1 block. Does that make sense? Everyone see that? You good? So it's kind of hard to see after looking at the screen, by the way. It's kind of bright. So that's 1, 1, 1, 1. So we have 5. There's one more. Does anyone know where that last one's at? No one knows where the last one is? Oh. Do you know?
Me?
Yeah.
Yeah.
What's your name?
Abby?
Abby. Come on, Abby.
Oh, okay.
I probably should have raised my hand.
That is always worth a try.
Oh, my bad. Okay. New square.
That's fine.
So then I just, sorry, can you see it? Okay, kind of. So then we have 1, 2, 3, 4. You can tell that's 5 right there. 6. You can tell that's 7, 8, 9, 10. 10.
You're right. Good.
I just kind of like estimate and
Well, you're
so
right.
I'm not like exact. I don't know how to not do it.
Well, no, that is one way. There's always more than one way. So if we just do this again. So we're going to do this matrix right. How about we do that triangle thing again? So we know what this is. This is 4. And then this is 1.5, 1.5, 1.5, 1.5. I need to learn how to write on projectors so people can read it right. But does everyone see how that works? How this is 1.5? Good? Coach? Now we're going to do an activity. Yeah, right. In this activity, you're going to be looking, it's called looking for area patterns. You have a better idea. So you can work in groups of 2 or 3. And I'll just read the opening. It says, looking for area patterns. You have by now become quite proficient at finding areas of figures that are rather irregular in shape or do not have convenient orientation. We will use that skill as we investigate the relationships among various shapes, specifically the squares associated with right triangles. Let's consider a right triangle with legs that each have a length of 1. See below left. Who would like to read the next part?
Just that suppose that you draw, is that what you want me to do?
Wherever I left off.
Okay. Suppose that you draw squares on the hypotenuse and both of the legs of the triangle. See below right.
Continue.
How are the areas of these 3 squares related? As we continue this investigation, look for a relationship among the area of the squares drawn on the sides of right triangles.
So I'll go number 1. For each of the rows of the table, draw a right triangle given lengths. So let's do the first one together. Length of 1. This is 1. Length of 1. I'll like 2. Now, what is the area of this square? 1. What's the area of this square? What is the area of this square on the hypotenuse? What is it? 2. Cool. And then you just continue on. And who would like to do, we'll do the second one together as well, but who would like to volunteer to do that? Come up here and draw another triangle and squares. Nobody? Come on. Give me red. Matches your shirt. Oh, I have to go to the sheet.
Okay, so a leg length of 2. Like that.
How about we do an area away from that first one? That way the squares won't. So just do it over here. And what's the length of it? There you go. Well, that's 2 down, but that works. We can do this one. So draw the squares, that's fine.
Okay. This 2.
Cool. And what's the areas of those squares?
So is that right?
What does everybody think? Okay. Is it 9, you think? Let's count. Let's count. What does it say?
Let's see.
So let's mark them off then. How about you mark them off for us?
Oh. Okay, now I'm
Confused.
confused.
That's
I'm
okay.
marking 1.5 ones.
That's fine.
Okay.
That's why we do this, to gain experience. Mistakes are good. You know why mistakes are good? Because you remember those mistakes
Yeah.
and you learn from them.
Okay, I thought it was 9, but then, because I'm not working off that size, I was working off the bigger ones.
Okay, that's fine. So we have these squares here. How many squares is this? Right here. Yeah, what's the area
That's
here?
a half and half, so, okay, so there's one and there's one, so there's two.
So we have 2. And here.
And two, and two, and two, so 2, 4, 6, 8.
8. There we go. The area of that is 8.
Okay.
Any questions? Cool. Let's do this. Let's break into our groups and get it done. What is this area? 9. And what is the area here? 18. And this is 4 and 3. We know that's 9. What's the area here? And the area of this box? 25? So, okay. Now, did anyone see a pattern? Who would like to say that pattern, or go for it?
They're all perfect squares.
All perfect squares, that's one thing. Yes, I like that. Anything else?
Those two areas added together as the first side to give you the area.
Say that again?
The two areas of the side, the first two triangles, or the squares that you drew give you the area when added together, give you the area of the third.
Another thing. So we can definitely see there's a pattern. But does anyone know what that pattern is, besides saying it? That's exactly what it is. The Pythagorean theorem. Perfect. And what is the Pythagorean theorem? Just tell me. A squared 9 plus b squared 16 equals 20. And then, so what is the length of this? 5. Here. So you said this is 18, right? And so this, what is this? Just tell me what is it 4.2? Or 18? If you have any questions, please let me know tomorrow or today or Thursday. Cool. And remember your homework.